Okay, here we have a division problem of rational expressions. So with rational expressions, they're just fractions, remember. So first thing is you want to rewrite it because dividing fractions is really multiplying by the reciprocal. So I'm going to rewrite this problem before I do anything. Okay. All right, and just like with fractions, most likely you want to try to simplify the problem down first before you actually try to do the operation of multiplication. So in order for us to know if there are common factors within this problem that will cancel out, to simplify it, we will have to write each one of these polynomials in its factored form. So we are going to look at each fraction and we are going to take it apart and we are going to factor each piece of each fraction. So I'm going to split my page and I'm going to start factoring. So first I have x squared minus 4. X squared minus 4 is a binomial. There's two terms present. We always check to see if there's a GCF when we're trying to factor. There is no greatest common factor here. The next thing you have to do, because it's a binomial, is ask yourself, am I looking at the difference, which means subtraction, of two perfect squares? Perfect square, something that has two of the same factors. So x squared is x and x. 4, 2 times 2. So because it's difference, this is the difference of two perfect squares. You do two sets of parentheses. The x squared is going to split as x and x. 4, we do the square root of 4, which is 2. One parenthesis is going to be a plus, and one is going to be a minus. Then we're going to break down and factor 3x squared minus 2x minus 8. This is a trinomial. We still always check for a greatest common factor. There is no GCF here. Because my A is not 1, I'm going to go A times C. That's going to give me a negative 24. So I need factors of 24, negative 24, that will create a 2. So you list your factors of 24. 6 and 4. If I do a negative 6 and a plus 4, I'll get a negative 2. If I multiply those two numbers, I'll get a negative 24. So I double checked, so those are my values. So I'm going to rewrite this as a 4-term polynomial. It's 4 terms, so now I'm just going to split it so I can factor by grouping. 3x, 2. So my two sets of parentheses are the same, so I know I did it correct. So I'm going to write x minus 2, and then I'm going to put together the 3x and the 4. And that one is factored. I'm going to my second fraction. I have 9x squared minus 16. Again, it's a binomial. We're going to check for a GCF. 9 and 16 have nothing in common other than 1. There's no x common factor, so then you have to see, is this the difference of two perfect squares? 9 is a perfect square, 3, 3. 16 is also a perfect square, 4 and 4. Your mind will want to tell you 8. 8 is added together to create 16. Squares are things that are multiplied together to create the value. So it's 4 and 4. So we are going to do two sets of parentheses. 3x, 3x, 4, 4. One's a plus, one's a minus. That one is factored. And then we're going to factor 4x plus 8. Again, I have a binomial. There's a GCF present. The GCF is 4. Factor that out. So now I'm going to rewrite my problem using the factors. All right. So now you want to see what can cancel. Remember, it has to be something up and something down because you have to create that 1. And the 1 is created from A over A, right? Anything over itself creates the 1. All right? So it just can't be across from each other, but they can be up and down from each other, okay? So x plus 2 can cancel with this x plus 2. It doesn't matter if it's in the other fraction. All that matters is that it is at the bottom and the other one is at the top. 3x plus 4 cancels with 3x plus 4. Again, they are on separate fractions, but that is irrelevant because one is up and one is down. X minus 2, x minus 2. That leaves us with 3x minus 4 over 4. And we are finished with our problem. We cannot cancel those 4's out. Please remember that, because you can only cancel factors. Remember, 3x minus 4 is its own factor. Okay? And so this would be your final answer. You don't have to have the parentheses. I just do. And that is it. Oh, and remember, I love math. And so do you.